You spend a week running an intense continuous improvement event. You eliminate waste, map out a highly efficient process, and celebrate on Friday afternoon when production time is cut in half. But come Monday morning, the new shift clocks in, ignores the new process, and goes right back to their old habits. Without a mechanism to lock in that new method, progress rolls backward. Think of your new process as a heavy boulder you have pushed up a hill. To keep it from rolling back down the moment you let go, you have to drive a wedge underneath it. In lean manufacturing, that wedge is standard work. We're going to look at why those 100-page, dust-covered instruction binders sitting in your office cabinets are failing your team. We will replace them with a single-page visual diagram mounted directly on the workstation. If you do not lock in a strict baseline for how a task is performed today, you have nothing to measure against tomorrow. Standardizing your current best method is the absolute first step you must take. Step 1 requires leaving your desk. You cannot build an accurate standard from an office chair. You need to walk out onto the factory floor, the gemba, equipped with a stopwatch and a camera. Find your most experienced, efficient operator. You want the person who produces 0 defects and hits their targets consistently. Record their exact physical movements. They serve as the raw baseline for your new procedure. When reviewing that footage, you catch the subtle physical techniques that make them so fast. You might see them tighten flange bolts in a cross pattern to prevent leaks, or cross their hands to grab parts, eliminating the need to twist their spine. This one-page template requires 3 specific data points. First, takt time, the exact seconds needed to finish one piece matching customer demand. Second, working sequence, the step-by-step physical choreography the operator's hands follow. Third, standard work-in process, a strict numerical cap on allowable unfinished parts. Enforcing these 3 limits transforms hidden tribal knowledge into measurable, objective rules. Now, draft your guide on a single sheet of paper. This document relies on photos and clear diagrams, keeping written text to an absolute minimum. Avoid the common error of letting an engineer write the standard alone in an office. A process drafted by someone who does not physically handle the equipment will likely be ignored. Build the standard collaboratively. The operators doing the work must dictate the steps, while the engineer acts strictly as a timekeeper and facilitator. Install this single page exactly where the work happens. Mount it directly on the machine, within 1 meter of the operator's line of sight. From this point forward, your master operator uses this exact physical sheet as the sole curriculum to train every new hire. Placing the standard right at the point of use ensures every shift receives identical instructions, removing the factory's reliance on flawed human memory. With the standard installed, a manager operates with the diagnostician's mindset, auditing the floor to spot any variation from the baseline. You verify the system using a 3-part test. First, check visibility. If you ask an operator to show you the standard and they have to open a drawer to find it, the system is broken. Second, check for updates. A pristine, yellowing document from 3 years ago proves 0 continuous improvement is happening. Your standard should be covered in fresh pen marks and crossed-out sections. Finally, check the escalation plan. If an operator misses takt time, the standard must explicitly tell them what to do next, like pulling an andon cord to alert a supervisor. A true standard is a sensitive alarm system. It highlights the exact moment a process drops below the baseline, allowing managers to intervene early. By following these steps, you are effectively duplicating your best worker's output across the entire line. This stabilizes your cycle times and provides a mechanism to identify and correct the variations that lead to defects. But standard work is never a permanent rule. It is simply the best baseline we have managed to discover as of today. The very moment a worker invents a faster or safer way to complete a sequence, you tear up the current sheet and write a new one. Now that your baseline is locked in, the next challenge is verifying it. How can a shift supervisor stand 10 meters away and instantly know if an operator is following the standard without micromanaging them? We will cover that in our next breakdown on visual management, because this unshakable foundation of standard work is what makes more complex automation and future scaling possible.